Ayan. So once again, good morning to everyone. So if you haven't yet filled up the attendance for today, the link for that one is on the Google Meet chat box. Kindly fill that one up. So for today, we'll try to go over our long quiz from last week. So last week, we had our long quiz covering LGs 1.1 to 1.5, namely our first law of thermodynamics and our second law, as well as the Gibbs energy. So in this quiz, we had the following questions. So first off, we had some true or false type questions, followed by multiple choice questions, and finally problem solving. Now for the problem solving, some of them were just asked to, we were just asked to input our answers in that one. And for the last two items that we had, so we were asked to also solve that one on a piece of paper, take a picture of that, and then upload the picture on KHub. So with that, let's now try to go over our long quiz from last week, starting with the multiple choice. So you have the first question here. So kindly please verify if you can see it on your screen, ang ating questions.
Yes, sir.
Makita, sir.
Okay, thank you so much. Sige, so number one. So sabi dito, the surrounding is the part of the universe that we are going to focus on in the study of thermodynamics. So this one is false. So can anybody recall if ano ba ang part of the universe that we focus on in thermodynamics?
The system po, sir.
Okay, thank you, Jazz. Thank you, Danielle, as well. So it should be the system that we are focusing on in our study of thermodynamics. So everything else outside of the system, that is your surrounding. Now for number two, so we had also seen in our PowerPoint that there are three types of systems. You can have a closed system, an open system, and an isolated system. Now we define an open system as follows. So an open system is any system that allows for the transfer of mass and energy from the surrounding to the system. So number two is true. Okay. So for the closed system, so that is the opposite of that one. So only energy can be allowed to transfer through the boundary in a closed system. While if you have an isolated system, so neither mass nor energy can transfer from the system to the surroundings. So those are the different types of systems that we encounter. So that's number two. We have number three. Number three tells us that we have the following. Enthalpy refers to the sum of kinetic and potential energies of all particles in the system. So this one is false. So it's not enthalpy, it should be entropy. Internal energy rather. The internal energy of the system is the sum of the kinetic and potential energies of all particles making up our system. So that's number three. Number four, we have this one. In a constant pressure process, delta E is equal to Q is false. So can anybody please recall for me, pag constant pressure process, ano nga bang ating equality dapat? Okay, so thank you, AC, for your answer. So in a constant pressure process, it is the change in the enthalpy that is equal to our Q. Namely, delta H is equal to QP. So delta E is equal to QP only if we have a constant volume process. That is to say, we have a process wherein our gas, if that makes up our system, is not allowed to expand or compress. So that's number four. Then we have number five up next. When the value of delta H is negative, a process is exergonic. So this one is false. So ano ba ang ating process if delta H is negative? Can you recall for me? Okay, thank you again, AC. How about the rest? So do you agree with AC? When delta H is negative, a process is blank. So what is our process when delta H is negative? Can anybody else recall? Okay. So we all agree naman. So exothermic process has a delta H with a negative sign. Now for number 6, so we're now talking about delta G. By the way, delta H that's positive, that is your endothermic process. Now number 6, so we have the following. When the value of delta G is positive, a process is endergonic. So this one is true. Same with number 7. So number 7, we have the standard state. It's defined as the condition wherein we have a temperature of 25 degrees Celsius and 1 atmospheres of pressure. Now for number 8, so we have the following. For liquid nitrogen at standard state, delta H formation at standard state is equal to 0. So this one is false. We know that this one is false because in our day-to-day experience, the nitrogen in our atmosphere is gaseous. So that is why liquid nitrogen is not the form of nitrogen at standard state. So that's number 8. We have number 9 up next. So for water, the solid phase is the most ordered, while the gaseous phase is the most disordered. So the answer for this is true. So if you look at the PowerPoint that I shared with you guys, so can you please organize this one for me? So you have solid, liquid, gas. So kindly organize this one from most disordered to most ordered. So you have the solid phase, the liquid phase, and the gaseous phase. So can you please organize for me? So which of these is gonna be able to display a greater amount of order and a greater amount of disorder? So paki-arrange lang, most disordered up to the most ordered. Okay, so we have our answers all coming in. So all the answers are agreeing. So we have gas as the most disordered, followed by the liquid, and solid as the most ordered of our phases of matter. So that is our number 9. Now for number 10, when the value of delta G is negative, the process does not require the input of energy to allow it to happen. So this one is true. When delta G is negative, guys, so this is when you have an exergonic na reaction. So when we have an exergonic reaction, so there is no need to input energy just to allow the reaction to occur. Now, in the opposite case, if delta G is positive, so we have an endergonic reaction. In endergonic reactions, you need to input energy into the system so that that added energy will drive the reaction, allowing it to happen. So that is now your number 10. So that is our true or false. So at this point, are there any questions ba regarding the true or false? Questions, clarifications, or violent reactions? Okay, thank you, Danielle. So that's the true or false. We then move on to the multiple choice. So in the multiple choice, we have the following. So we have this definition here in number 11. So blank is the energy transferred between the system and its surroundings as a result of a temperature difference only. So this is the definition of heat. So we know that heat is transferring from an area of higher temperature to an area of lower temperature. So that is how heat is being transferred. And we also have number 12. So number 12, this comes from the PowerPoint that I shared with you guys. So this is an additional material that I added on to our LGs. So our gas molecules can have any of the following components of motion except for transcription. So for those who are bio-oriented, so transcription is related to that one. So when we talk about translation, translation is the motion going from point A to point B. So this motion is translation. So rotation from the name itself, so our molecule is able to rotate along an axis. So it can rotate along the x-axis, the y-axis, and the z-axis. And meanwhile, so for molecular vibration, what we mean by this is, so just imagine that my two fists here represent the atoms in the molecule, and between my two fists, so there is a chemical bond. So when we talk about molecular vibration, it is the action wherein ang ating atoms can either stretch or compress our chemical bond. So that is the molecular vibration. So that's number 12. Number 13, so we encounter here the definition of the Clausius statement. So the Clausius statement tells us that it is impossible to construct a refrigerator that transfers heat from a cold reservoir to a hot reservoir without aid from an external source. So that's number 13. Then we have number 14 up next. The following statements about the heat of reaction is true except for letter D. So in here, so it's already highlighted sa letter D. So actually, the heat of reaction depends on the amount of reactants consumed. You might recall in our Hess's law discussion, if I multiply all of the quantities in the thermochemical equation by 1/2, let's say, so if I have the reactants, ang delta H, maha-half din siya. So the heat of reaction is actually dependent on the amount of the reactants. So likewise, if I increase the amount of reactants by 2, so the heat of the reaction also increases by a factor of 2 as well. So that's why letter D is incorrect. And number 15, so we have the following. So when delta H thou and delta S are both positive, which of the following is true? So in here, in number 15, we have to go back into the definition of delta G. So for the sake of this one, let me type in the equation for delta G in here. So delta G, if you might recall, is equal to delta H minus E delta S. Now, our absolute temperature is always going to be positive. So, that is going to be fixed for us. And we also know na for a reaction or a process to be spontaneous, ang delta G dapat is having a negative sign. So, kailan lang ba siya magiging negative? So, in here, you have a situation wherein delta H is positive and our temperature, as I mentioned, is always going to be positive when you're talking about absolute temperature, and delta S being positive as well. So you can imagine, guys, So if the temperature is quite low, so a positive minus a very small quantity, ang lalabas is positive lamang. So the only time na magiging negative itong term on the right is if ang ating second na term in here is gonna have a large value. That is to say, when our temperature is high. So therefore, we then say that for number 15, the process will only be spontaneous at high temperatures. So if we should ever encounter a process having a positive delta H and delta S, we then know for it to be able to proceed on its own, kailangan lang natin taasan ang temperature just for it to be able to happen spontaneously. So that's numbers 11 to 15, the multiple choice. So at this point, let me check in on you guys. So any questions ba regarding this one? The numbers 11 to 15? Any parts that you'd like me to clarify to you? Okay, so thank you for the feedback. How about the rest? So okay lang ba? Gets lang? So numbers 11 to 15? Okay, thank you so much, Raf and Zed as well, and Sham. So with that, let's now move on to the problem-solving portion. So you have the following. So in number 16, we have the following na situation going on. So the system is said to be absorbing heat while 35 joules of work is being done on it. So we're dealing with internal energy here. So for the sake of this one, let me type in the equation for internal energy. So we have a guide on how to answer this. First off, in number 16, so we're asked to determine the following. So first, what is the sign of your Q? And also, what is the sign of our W? So reading the situation again, so can you please tell me for number 16, so ano ba ang sign ni Q and W? Okay, so Danielle and AC and Sham have their answers. So kay Sham, positive ang Q or positive ang W? So, or are they both positive? Okay, ayan. So, AC, Sham, and Danielle all agree, as do I, that reading this particular na situation, we have a positive Q and also a positive W. So we know this because ang sabi dito, you have the system absorbing heat. So when the heat is being absorbed, so that tells us that Q is positive in value. Likewise, when work is being done on the system, like in this case, ang work natin also has a positive sign as well. So moving on to letter B. So can you please compute for me as well? What is the change in internal energy for the system? So let's use this equation over here. You know. So how much is the delta E for this particular situation in number 16? So as you mentioned, ang Q natin is positive. So that's positive 72. And work is also positive. That gives us positive 35 joule. So how much is this going to be equal to? So we have Z and we have AC with their answers. So this is correct. So in here we have the delta E is equal to 107 joules. So let me type that in. This is 107 joules. And since our delta E has a positive sign, that tells us that the internal energy of the system is actually increasing. Nadagdagan siya by exactly 107 joules. So if the opposite was true, so if you have delta E having a negative sign, so that tells us that the internal energy of the system is actually decreasing. So positive delta E, increasing internal energy. Negative delta E, decreasing internal energy for the system. So that's number 16. Number 17 also deals with internal energy pa rin. So letter A, so actually we need to be able to solve letter B pa muna to be able to answer this one. So in this particular situation that we have in number 17, so it says here that our sample of gas absorbs 80 kilojoules of heat. Additionally, it also expands from 400 liters to 900 liters against a constant pressure of 200 kilopascal. Now, if you recall, our work being done by the gas as it expands is given by this equation that I'm typing right now. So work for an expanding gas is equal to negative P times the delta V, wherein our delta V is equal to the final volume minus the initial volume. So since we're looking for the work in kilojoules here, we need to first convert this one, the unit of the volume, from liters into cubic meters. So you were given a hint in here. So in the hint that was given to you guys, so we know that 1 cubic meter is actually equal to 1,000 liters. So we need to convert first the volume from liter to cubic meter. Please don't hang. Ayan. So using our calculator, we can convert this one quite easily. So 400 liters, can you please convert it for me? So how much is 400 liters in cubic meters? So anybody who can compute for us how much the volume in cubic meters is for 400 liters?
0.4, sir.
Okay, thank you, Jibril. So we have 400 liters, which is the initial volume, equal to 0.4 cubic meters. How about the final volume? So how much will it be in cubic
0.9, sir.
Okay, that's correct as well. That's 0.9 cubic meters. And we multiply that one to 200 kilopascal. So using my calculator now, I can then compute the work for this one. So work is equal to negative 200 kilopascal times the difference here is 0.5. So the work is equal to negative 100 kilojoules. So now that we have the value of the work, we can then answer the letter A. So first up, what is the sign of...
Sir. Before that. Kaya di ba, ay wait, ang sa formula dyan, mauna yung, ay initial minus final or final minus initial?
Final minus initial.
Oh. So, kung ganun sir, di ba ang magiging resulta is like doon sa, what was it called? Yung M cube. Sa meter cube is, di ba, 0.5 kay di minus yung difference.
Yes.
Bakit kung i-multiply siya sa, oh, wait, never mind. Nakita ko na yung negative.
100 times
Nakita ko na.
0.5.
Meron palang negative sa tabi ng 200.
Yes. So please don't forget the negative sign. So the formula for work done in expanding the gas is negative P delta V. Okay? Sige. So thank you for the question, Jibril. Let's now try to answer letter A. So what is the sign of Q muna? Obviously, ang work is negative. How about the work? How about the Q rather? Okay, so thank you, Earl, for that one. So since, again, the gas is absorbing heat, so positive ang sign ng ating Q. So all that's left to do now is to input our given value na 80 kilojoules of the heat with the work that we've computed, which is negative 100 kilojoules. So using the formula that we have in here for delta E, so let me copy that one to minimize the typing. So delta E again is equal to Q plus W, and this one is equal to 80 kilojoules plus negative 100 kilojoules. So with this, we get our delta E value. So delta E is then equal to negative 20 kilojoules. So since the delta E has a negative sign, we then know na ang internal energy ng system has decreased by a value of 20 kilojoules. So that is number 17. So Jibril already asked the question for number 17, letter B, but let me check in on the others as well. So are there any questions pa ba regarding number 17 on how we answered this one? Okay, thank you so much, Earl. Sige, so we have our number 18. So by the way, if you need this one to be able to study for our exam, so I will be sharing the answer key lang naman on K-Hub, so you can just review how we were able to solve these problem-solving na questions. Now, as for number 18 rather, so there were a couple of questions asking, so mauuna ko ba i-answer si letter A or si letter B? Since there are two drop-down menus. So, K-Hub is checking it. Letter A ang naunang ating drop box or naunang drop-down menu. And the second drop-down menu is our letter B. But don't worry, I always double check naman the answers of your answers as well. So if I see na mali lang ng input, maybe because na mali lang ng display si K-Hub dyan, or hindi masyadong klaro ang pagka-present ng question, so I can still manually correct the points that you get for number 18. So in number 18, letter A, you already have the clue in here. Number 18, letter A, is an endothermic reaction. So based on this fact that you have an endothermic reaction, so can you tell me, is the enthalpy of the reactant greater or is the enthalpy of the product greater? So which will it be for the letter A? Is enthalpy of reactant greater or enthalpy of product greater than? Excuse me. So any ideas? For letter A, is H of reactant greater than H of product? Or is H product greater than H reactant? Okay, so AC says product is greater with a lot of question marks. So Raf also agrees product is greater than reactant for the enthalpy. So in here, since you have an endothermic reaction, so we then know na, in this case, our product has a greater enthalpy than the reactant. So that, if we subtract product minus reactant, we get a delta H that is positive in value. And we know naman na pag endothermic yan, ang delta H has a positive na sign. So that is for letter A. So the opposite is true for an exothermic na reaction, like in letter B. So in this case, since it's exothermic, the enthalpy ng ating reactant is greater than the enthalpy of the product. So that if you subtract the small product to the greater enthalpy of the reactant, delta H is then going to have a negative sign. So that is the case for an exothermic reaction. So that is the number 18. Then at this point, we move on to our number 19. So number 19, you have your one possible type of fuel to help our reusable booster rockets to be able to go into space. So our booster rockets can use a mixture of aluminum and ammonium perchlorate as the fuel. So the reaction for this one is given to be the following. So from this possible reaction that's already balanced out, we are now asked to calculate the delta H at standard state for the reaction using the standard enthalpies of formation of the reactants and products in Appendix B of our textbook. So sabi dito, if the enthalpy of formation is not in the textbook, you are free to search the value on the internet. So let me zoom in a little bit. So in here, so if we now have the Appendix B na standard heats of formation, we can then use our Hess's law equation, which is the following. So from the Hess's law, I can then compute delta H for the reaction at standard state. So this is now equal to the following. So delta H, nasan ka? Ayan. Delta H reaction at standard state is equal to the summation of the stoichiometry coefficients ng ating products times the standard enthalpies of formation for our products minus the summation of the product ng stoichiometric coefficients ng ating reactants times their standard enthalpies of formation. So you can refer to your Appendix B of the textbook for this one. So we have the following. So delta H of the reaction can be computed as follows. Starting with the products, we have the following. So unang-una, we have our aluminum oxide, Al2O3. Coefficient is 1. So I then type here. So that's 1 mole, times, from Appendix B of the textbook, I can find there the standard heat of formation of the aluminum oxide. So this is negative 1676 kilojoules per mole. To this one, I add the term for aluminum chloride. Aluminum chloride in the balanced chemical equation here has a coefficient of 1. So I then type 1 mole pa rin times the heat of formation ni aluminum chloride, which is, again from the Appendix B, equal to negative 704.2 kilojoule per mole. Continuing on with our products, we have 3NO. So NO has a coefficient of 3. So I then type the following. So that's 3 moles of the NO. And for its heat of formation, so looking at my Appendix B, so I have my NO gas having a heat of formation equal to 90.29. Okay. Plus, finally, the last product that we have is the water. Coefficient niya is 6. So I then type 6 moles of the water gas times its heat of formation. So for the water gas, so I have a heat of formation equal to negative 241.826. So that takes care of all our products. To this, we subtract then our reactants. So for the reactant side, we now have the following. So we have first reactant is 3 aluminum. So since coefficient of aluminum is 3, I then write 3 moles rather. And from my appendix B, I can see that solid aluminum at standard state has a heat of formation equal to 0. Plus, for my ammonium perchlorate, so I have the following. So 3 moles pa rin, since the coefficient of this is 3, times the standard heat of formation for ammonium perchlorate. Now, if I look at my appendix B, so I don't see the value for this one, for the heat of formation. So what I can do, I can just search for it on the internet. So heat of formation of NH4ClO4. So understandably, we will have different values depending on the sources that we find on the internet. So what I just found right now from the internet is the following value, negative 295.77. So to take into account the differences in values nito, so our K-hub is allowed to compute for a range of values. So any value close to the computed value that I have will be considered to be correct. So kindly please use your calculator. Can you please compute for me how much ba ang ating delta H of the reaction at standard state for this reaction? So kindly please compute that one for me. In the meantime, to maximize the time that we have for this morning, so what I'm gonna do is I'll just type the solution as well for number 20 while we compute the number 19. So kindly please compute how much ang delta H for this reaction that we have in number 19. The solution is above on the screen. So when you report your final answer, please don't forget the unit. And also, please be sure to report it to the correct number of significant figures. Okay, so how much is the delta H? So we have an answer from Sham. Can I hear from the others in the class? So other people who haven't yet volunteered for today. So perhaps I can hear your answers for this one. So we have an answer from Phileus as well. So he agrees with Sham. So maybe one more. So anybody else who might have a different answer for delta H? Okay, so AC also agrees. So I also agree with them. So this one is equal to negative 2673 kilojoules. So that is our delta H. So again, let me reiterate in case that you're worried about your answer. Since we might have different values for the keto formation ni NH4Cl4, ClO4 rather, since we look at different sources on the internet, so I already had KHub check answers that are close to this value. So as long as close lang naman siya, it will still be considered as correct. So that's how you compute the delta H for this reaction using our Hess's law. Now for number 20, while I ask you to compute the number 19, so I already typed in here the solution for this one. So you might notice in number 20, ang kanyang equation that we use is very similar to Hess's law. I have to emphasize na similar siya, but they are not the same since this equation is not Hess's law. Ang Hess law is only for our enthalpy lamang. So this is the Hess's law. This one, similar equation, but not Hess's law. In number 20, so the answer that I get, so thankfully all of this is in the Appendix B of our textbook. So delta S for this reaction is equal to negative 128.72. So that's what I get using my calculator. Or expressing this one to the correct number of significant figures. So this one has 1 decimal place, 2 decimal place for this one, 2 decimal place for this one as well. And for our last entropy, so this has 1 decimal place. So my final answer should also have 1 decimal place as well. So my answer that I'll report is negative 128.7 joule per Kelvin. So that is now your number 20. So numbers 19 and 20. So at this point, let me hear from you guys. So any questions ba on how we answered this one? Okay, thank you so much. Sige, let's try to make the rest as quick as we could. So we have numbers 21. So last 3 questions na lamang. Let's just try to finish it so we don't have to meet later this afternoon. Number 21, so we have the following information. So we have the delta H value and the delta S also given at 25 degrees. So this is actually a very direct na question lamang. All we need to do is just to use our definition for delta G. So delta G at standard state is then equal to the delta H minus T delta S. Substituting the values, we then have the following. So delta H is given to be equal to negative 285.4 kilojoule per mole minus the temperature. So we still need to convert muna the degree Celsius into Kelvin. To do that, we just add 273.15 to turn it into Kelvin times the entropy change, which is 137.55 joule per mole K. So inputting this one to my calculator, so I then get the value of the delta G at standard state for this particular na reaction. So this time, so I have the solution already. So plugging that into the calculator, negative 285.4 minus 298.15 times 137.55 divided by 1000. So my answer here is negative 326.4 kilojoules per mole. So that is for number 21. So number 21, it's a little bit direct to the point. Unless there are any questions on how we answered number 21. Questions on number 21? So if there's none, so very quickly lang talaga guys, so that we don't have to meet later on. So you can use the time later for finishing your other formative assessments. Number 22. Number 22, so we have the following information given to us. This time, so we are now asked to solve this one on a piece of paper, and then we are supposed to then upload our picture, take a picture of our solution rather, and then upload it to K-Hub. So we're given the mass of our Fe2O3. So it's 1 gram of this one. And from this, we're supposed to find as well, how much heat is generated when 1 gram of the Fe2O3 is reacted. So quick review lang. So we have the thermite reaction going on in here. So the thermite reaction is used in welding. So if you have seen welding happening, so you might notice that our welders use a very thick visor. So our thermite reaction is a very highly exothermic na process. So it releases a lot of heat energy, and some of that heat energy is turned into light. So that is why you also need your visor to protect your eyes from the brightness of that one. So to solve this one, so we have the following. So it's a very highly exothermic reaction. So it releases so much heat that it is able to melt our different metals. So to answer this one, what we need to do is we start off with our given value. So Q can be computed from the amount of the Fe2O3 we were given. And this amount of Fe2O3, we then divide it by its molar mass. So by dividing this 1 gram of Fe2O3 by the molar mass, we can then compute the number of moles of Fe2O3 that has reacted. So in this one, you were given a periodic table to use so that we have the same na values that will come up when we do the computation for this. So computing this one, molar mass of the Fe2O3, I have 55.845 times 2 plus 15.999 times 3. That's 159.687. For every 1 mole of the Fe2O3. And now that we have the number of moles of Fe2O3 that has reacted, we then now make another conversion factor using our thermochemical equation. So I'm not yet finished with checking for our section. So a common mistake that I see in your section as well as other sections is that nai-include natin ang negative sign ng delta H. So the negative sign, we don't include it in here anymore. We're simply interested in the value of delta H. But in any case, so even with that small mistake, if I see naman na everything else that you did is quite correct, so I would still give you guys partial points lang naman. So no need to worry that you get a bad score because you missed that particular detail. So just remember na, do not include the negative sign in here. It's only the value of delta H that is important when we do stoichiometry computations. So any other na mga small mistakes like baka na mali lang ng compute or mali lang ng enter sa calculator. So again, I look at these solutions talaga carefully. So I can still give you partial points even if you don't get the correct value. For this one, the heat that is produced is 5.33 kilojoules. Okay. So number 22. So very quickly lang. So let me check in on you guys. I hope you're still with me. So any questions on how we answered this one? Okay, thank you so much, Raf. And finally, we have number 23. Number 23, we again have the Hess's law, but this time you're given the thermochemical equations to be able to answer this one. So for this one, so using the three thermochemical equations, we then are asked to compute the delta H for this reaction. So in here, so what we have is CLF first for the reactant. You have a CLF here for our first thermochemical equation, but it is multiplied by 2. So what I can do, I'm just giving you the outline of the solution for this para lang mag-save tayo on time. So we don't have to wait any further for this to end. But if you're going to answer this one, I need your complete solution, not just the outline. Again, outline lang ang ilalagay dito just so we can save on time for this particular sync session. So for the first na thermochemical equation, so what I do is I multiply this first equation by 1/2. Para lang ang ating CLF in here has the same coefficient as my overall equation. Now for the second thermochemical equation, so it has the CLF3. Ang coefficient dito is 2 and nasa reactant side siya. Meanwhile, in my overall reaction, so the CLF3 has a coefficient of 1 and nasa product side. So for the second thermochemical equation, what I then do is I multiply this one by 1/2 as well and then reverse that one. So that ang CLF3 na ito now ends up on the product na side. And finally, for thermochemical equation number 3, I once again multiply this one by 1/2. Para lang si fluorine in the third thermochemical equation has now a coefficient of 1. So doing that, I should then be able to compute the value of my delta H. So for this one, I have my delta H value. So let me compute it very quickly lang. So this one is then equal to negative 108. Oops. 108.7 kilojoules. And since you have a delta H that has a negative sign, so this one is an exothermic reaction. Again, very important lang, let me remind you again, I'm just giving the outline of what my solution would be to save on time, but please don't give me this one when we have our exam and other quizzes. So what I need is the full solution for this one. So the full solution will be made available lang on K-Hub for you to be able to access. So you can just check the full solution there. So in the meantime, so let me check in on you. So any questions ba regarding this one? Our final question.
None na po, sir.
Okay, thank you, Jazz. Sige, so at this point, let me remind you of our attendance. So please be sure to fill that one up. So for this afternoon, since we're already done with the review, what I'd like you to do is use the remaining time to be able to answer any formative assessments that you've missed. Okay? So since we're done with the review, so we don't have to meet anymore this afternoon. So at this point, I'd like to thank you guys for your active participation. I hope you've learned something from today's session. So enjoy the rest of your day and have a great weekend ahead of you.
Thank you po, sir.
Bye, sir. Thank you, sir.
Thank you, sir.
Thank you guys. Bye everyone.
Bye po.